Before we dig our heels into this question, I want to just revise two important principles. One is the laws of exponents. So if you have something like this, x to the power of 2 times by x to the power of 3. And the important thing to notice here is the multiplication of two base numbers that are exactly the same. It would also work if you have numbers, 2 to the power of 2 times by 2 to the power of 3. We've got multiplication and we have the same base numbers. What happens in a case like this is you just simply add the exponents. So that will be x to the power of 2 plus 3, and this will be 2 to the power of 2 plus 3. You never multiply the base numbers in the final answer. Obviously you multiply them because that's how the first exponential law works. You need to multiply so that you can add the exponents, but you won't get 4 to the power of 2 plus 3. That will never happen. The base number stays exactly the same. This then is the first exponential law. Then if you divide the base numbers, let's say you've got x to the power of 3 divided by x to the power of 2, we normally in algebra write this using fractions. We very seldom use the division sign. So we'll write this as x to the power of 3 over x to the power of 2. And then the second exponential law says you just take the bottom exponent and subtract it from the top exponent, and that will then give you x to the power of 3 minus 2, which is just simply x to the power of 1. This is the second exponential law. Then we have the third exponential law, where you've got something in brackets, and the bracket is raised to an exponent. What you do in a case like this is you just multiply the exponents. So that will then give you x to the power of 2 times by 3. This is the third exponential law. Now, what happens in a lot of textbooks is that they would, for instance, look at the second exponential law and say what happens if the top exponent is smaller than the bottom exponent. So you've got x to the power of 2 divided by x to the power of 3. If you now subtract the bottom exponent from the top, you'll get x to the power of 2 minus 3, which is x to the power of minus 1. Obviously, because the fact is that you've got the minus 1 because of the subtraction process. If you subtracted the 2 from the 3, you would have had x to the power of 1 below the line. Now, to put this into perspective, what we have above the line is 2 x's. Below the line, we've got 3 x's. So if we cancel them out one by one, x goes into itself once and into x once, x goes into itself once and into that x once, what you have left is a 1 above the line and x below the line. And that's exactly what that means. The minus exponent just simply means it goes to the bottom and becomes a positive. So for instance, if you have something like, for argument's sake, 2x to the power of 2, let's write that down, 2x to the power of, let's say, minus 2. You need to observe the fact that that 2 has its own exponent, which currently is plus 1. So the 2 doesn't go to the bottom. The 2 will stay on top, but the x to the power of minus 2 will go to the bottom and become x to the power of positive 2. It's very important that you can see that process of how the negative exponent becomes positive when it goes below the line. But ultimately, this is still the second exponential law. Another variation on the second exponential law is if you have something divided by itself. So let's say you've got x to the power of 2 divided by x to the power of 2. Doesn't matter which way you subtract, you'll get x to the power of 0. But we know that anything divided by itself is always equal to 1. So according to the second exponential law, you get a 0 exponent. According to normal logic, you will get 1. So obviously, those two need to be exactly the same, which means anything to the power of 0 is always equal to 1. It's just another variation of the second exponential law. It's not a fifth and a sixth law, it's still the second law. And the same goes for the third exponential law. If you have more than one term inside the brackets, so let's say for instance you have 2x to the power of 2, y to the power of 3 over z to the power of 4, everything in brackets to the power of, let's say, 5, again you need to see that the 2 has got an exponent of 1, even if it's not written there, And then you just simply multiply every one of the exponents with the exponent outside the bracket, which will give you an answer of 2 to the power of 1 times by 5 is 5, x to the power of 2 times by 5 is 10, y to the power of 3 times by 5 is 15, and z to the power of 4 times by 5 is 20, and that's your final answer. But it's still the third exponential law. It's not a new law. It's not suddenly the fourth exponential law. It's still the same law. And this is the problem that we are seeing in this specific exercise, where they would expect you to use what they term sometimes the fourth exponential law, but it's just still the first exponential law. So just see the fact that that 3 is got an exponent of 1. So you multiply every one of the exponents, and the same with the b to the power of 1. Just multiply everything with the exponent of the bracket. So that will give you 3 to the power of 1 times by 2 is 2, a to the power of 2 times by 2 is 4, b to the power of 1 times by 2 is 2. The second question, however, you need to see the fact that there is a plus. That plus means there's a plus and a minus inside the bracket. It means it's no longer the exponential laws. What needs to happen in this case is the multiplying out of brackets. So that will be 2 brackets 3a squared plus b times by 3a squared plus b, and you need to multiply the brackets out by taking the first term in the first bracket and you multiply it with every single one of the terms in the second bracket, and then the second term in the first bracket, and you multiply it with every one of the terms in the second bracket. So essentially you've got 1, 2, 3, 4 arrows, and every arrow is a multiplication, and with that you can apply the first exponential law if you have to. But this is not from the beginning just multiplying that 2 in as you did with the previous question. Then looking at the next one, question number 3, you need to see that part there as the third exponential law. So you do that first. That will give you 2 to the power of 1 times by 3 is 3, x to the power of 3 times by 3 is 9, y to the power of 2 times by 3 is 6. Put that inside of a set of brackets, and then you multiply with the 3 outside. Now this brings me to an important discussion of multiplication and division in algebra. I normally call it the SNV rule. It stands for signs, numbers, and variables. And do your multiplication and your division in those 3 distinct steps by multiplying everything, all the signs, then the numbers, and then the variables separately. Now in this case, the 3 is a plus, because if it had to be a minus, it would have been a minus. And the 2 is also a plus, because if it was supposed to be a minus, it would have been a minus. So multiplying the signs means you multiply the plus and the plus, that will give you a plus. Then you move to the numbers, second step. Now 2 to the power of 3 is 8. 2 times 2 times 2 is 8. Multiplying the 3 and the 8 will give you 24. And then the variables. But there's nothing from outside the bracket to multiply with the variables inside the bracket, so it just remains x to the power of 9, y to the power of 6. So just take note of 2 very important things here. If it's not just simply the third exponential law, when you have a plus or a minus inside the bracket, we've got the same over there at question number 5. This minus here at number 4 is not what I'm referring to, because that will form part of the SNV rule. But when you've got more than one term inside the bracket, there we've got 2 terms, there we've got 2 terms, then it is no longer the exponential law. So remember that. Second thing to remember is when you've got numbers outside, such as there, and there, and there, and we can see maybe some more. No other ones have got numbers outside. So none of the other questions have got numbers outside. But if there is a number outside, remember the SNV rule for multiplication. And other than that, if you have a multiplication such as that, you can just add the exponents and then multiply with the exponent outside. With number 7, there is a plus, however, because you are working with numbers, you can work them out and add them together and then you will get a final answer. The same with number 8. You can actually work that out and multiply them with each other, because you cannot add the exponents. We've got separate base numbers. You can't add the exponents. That is also just a normal multiplication of numbers. With number 10, you have to be very careful though, because you've got 18 and 9, and number 11 you've got 12 and 6. You can still work them out because the exponents are exactly the same in number 10 but not in number 11. So my suggestion for you is to learn how to use prime factors. Whenever you are working with exponents, you'll notice up to now we've been working with prime factors 2 and 3. Now suddenly you are working with 18 and 9. That doesn't really count, because 16 and 625 are two reasonable numbers. You can multiply them. You can do this in exponents if you want to, but it's easy enough to do the multiplication of the two numbers. But looking at number 10, 18 to the power of 5 is a very big number. 9 to the power of 5 is a very big number. So rather work with your prime factors. So you write 18 as 3 to the power of 2 times by 2. 9 times by 2. Put that in brackets and then add the exponent. Below the line you've got 9, which is 3 squared. Put that in brackets and add the exponent. Now it becomes the third exponential law. So that will give you 3 to the power of 10 times by 2 to the power of 5 over 3 to the power of 10, and then you'll notice how easy those will cancel, and your final answer would just be 2 to the power of 5, just by working with prime factors. And the same goes for number 11. The 12 is 4 times by 3, or 2 squared times by 3. Put that in brackets, add the exponent. Below the line, 6 is 2 times by 3. Put that in brackets, add the exponent. And then you use the third exponential law, which will then give you 2 to the power of 12 times by 3 to the power of 6, divided by 2 to the power of 8 times by 3 to the power of 8. And then you just use the second exponential law for every one of the two bases, the 2's and the 3's. So that will give us 2 to the power of 12 minus 8 is 2 to the power of 4, times by 3 to the power of 6 minus 8 is 3 to the power of minus 2. And obviously then that minus 2 can go to the bottom, so this becomes 2 to the power of 4 over 3 to the power of positive 2. And that in turn can be simplified easy enough, because 2 to the power of 4 is 16 and 3 to the power of 2 is 9, and there you've got your final answer. So I hope this makes sense. Just be very wary of when you are supposed to be using the second exponential law, when you are supposing to use the distributive law, which is the multiplication of brackets, and when you've got more than one term or more than two terms being multiplied. For instance, if you've got something at the front of the bracket, when you need to use your SNV rule. Okay, and then obviously, like I said right at the end, a suggestion from me is to learn right now as quickly as possible to work with products of prime factors. That will help you a lot in later exponential calculations.